Hello all. This class will discuss types of digital thread. So basically we have digital thread. We will discuss this part. It is the documentations you can say, which will describe overall information of product, start from design to final product development. So it is indications of design, productions, design simulations and production part. So basically you should know what kind of different types of models are used in this digital thread part. The first part is we have digital geometric models. Okay. So this is a CAD-based model for product visualizations. So we can develop this product based on CATIA, SolidWorks, Creo or Pro softwares for the visualizations purpose, for product visualizations purpose. Then we have physical-based models. So again, after developing that product, we can perform FE analysis, CFD analysis, or structural simulations for this physical-based model purpose. Then third, we have machine learning and AI models. We have this data-driven model for predictive analysis purpose. And lastly, we have system level models that is integrating different subsystems for complete system behavior prediction. So this is the overall types of models. Now, if you go with the simulations and validations part, after developing that models with the help of these various CAD softwares, we have to perform the simulation and its validation. So suppose if you want to analyze this product by using FEA, like finite element analysis, you can simulate under this finite element analysis, you can simulating the mechanical stresses, we can simulate the heat transfer, material deformation, we can analyze the frequency, we can perform model analysis of that particular uh, component, okay, and overall stress, strain, deformation, pressure variation, then different stresses, field stress, ultimate stress. That part we can calculate by performing finite element analysis. Then second, computational fluid dynamics CFD. So if you are analyzing that particular part for various fluid flow, then you can perform the CFD. We can analyze this CFD for redundant shapes for vehicle designing. We are performing CFD to analyze the impact of uh, airflow on the car, okay, on the overall efficiency of that car. That can be analyzed with the help of CFD. Then we have third part, multi-physics simulations. Okay. So by implementing these different thermals, coupling thermals, uh, mechanical for systems, like suppose if we have different components, then that part is connected to electrical devices like we have sensors. So we can integrate these all these parts, like if you want to analyze any IC engine or CI engine. Okay. So that can be analyzed with the help of the softwares, but where we are implementing this thermocouples, we are analyzing the overall pressure variation, temperature variations. Okay. And that data can be simulated with the help of this different systems. Okay, system integrations. Then we have data-driven model training. Okay, so we have discussed this part. We have AI and machine learning algorithms we are using. These different training models are available in large data set to recognize the pattern and predict the outcomes. Okay, then we have neural networks and deep learning. So again, this is the advanced technology which is useful for complex decision making. Suppose if you are analyzing any autonomous vehicle or any medical diagnosis purpose, for that purpose we can use this neural network part or deep learning part. Then big data and cloud computing. Okay, so again, we have discussed this part. So various tools are available. Data analytics tools are available. Where large number of data can be processed, and based on the requirement, we can check the different performance of that system. Okay, with the help of big data tool, we can segregate that parameter with the help of big data tool. Then benefits of digital thread and model development. So overall, basically, why we are implementing this part to improve the product design, we need to enhance the product design. So based on the continuous data feedback, okay, that can ensure the better design and can minimize the error. Then faster prototyping and validation. So this digital simulations can reduce the physical need of physical prototyping. So virtually we can develop the prototype. Virtually we can develop that particular systems and we can analyze that part. Virtually we can simulate and virtually deliver the full product can be analyzed with the help of this part. Then optimize the manufacturing processes. We can optimize the overall decision due to this real-time uh, big data machine facility. With the help of this big data part, we can take the decision and we can enhance the efficiency. We can reduce the waste. Then we have enhance the predictive maintenance. So we can reduce the unexpected failure. Okay, we can reduce the downtime in industrial systems. Then live updates. That means based on the feedback of system. Okay, company can take the decision based on this available feedback for different operational changes. Okay, that facility is available. Now look at the flow, how the digital thread is functioning. Okay, what how you can say that your system is performing well or not. Okay, now look at the analysis. Like what we have product type of digital twin, we have process digital twin and several digital twin. Now this is integrations. Okay, now what we have discussed up till now, okay, how that system is integrated start from product. Okay, so product will be defined or it can be designed based on the requirement from customer. Okay, then digitally we can check the manufacturability, serviceability, whether it is possible to develop that product as per the requirement or not. Then AR/VR technique is used to virtually analyze the overall performance of that particular product. Okay, so start from the requirement, the based on the requirement of customer, we can start the development of product. Then we can conceptualize that design with the help of software tools. We can develop some kind of prototype, and then we can perform the simulations. So once the product is developed, then we can integrate that particular product for different simulations purpose. Like we have discussed FA, we can do CFD, we can do multi-physics analysis. Okay, so this is the first part where we are talking about the product digital twin. Then the second is we have process digital twin. Okay, now this system, suppose once we develop this product, then we can integrate this product. Okay, and we can analyze the overall requirement, how we can save the material, how we can save the particular usages of that product. That can be analyzed under this process digital twin. Okay, so again, this suppose a simulation network, if you have developed any particular part with the help of simulation network, we have developed say any production line. Okay, then it can be analyzed in this process digital twin. So again, AR/VR or technology with the help of AR/VR, we can develop this particular system. We can develop prototype for that simulation line, sorry, for that process line. And then after this part, we can vary the multiple parameters. Like suppose if we are talking about shaft assembly or shaft manufacturing, based on the required conditions, we can check this part and then we can analyze this overall performance of that particular system. Okay. Then service digital twin. Under this, we can maintain and optimize this part. So these are the different requirements. To look at the flow, how start from basic uh, requirement of product, how that system can be analyzed, how we can use this AR/VR tools to check the virtually to develop this product virtually and check the overall performance of that system. So this is the one more facility which we have. That is one more advantage we can say under this digital twin and digital thread part. Okay. Now look at the flow. So physical space. So based on we have this requirement, how that information data physically what we require based on the customer, we can start the design. Then based on the design, as per the design, we can select appropriate manufacturing process or we can select the overall manufacturing process flow and then finally that product will be manufactured. But if you look at the different processes, start from designing, model-based designing, from model-based manufacturing, model-based actual usage of that component, then rework, recycle, and finally to predict the failure of that particular part. So this part will come under this digital thread. So overall information from start to final end, or we can say launching or release of that particular product, we can select all the information under digital thread and virtually we can doing all these things. Okay, so virtual specimen digital twin is as per the required products. Yeah, before manufacturing the actual products, we can virtually simulate this part. We can virtually design this part, and we can check the performance whether the system is working well. Okay, so this is all about digital thread. We have discussed this part, different types of digital thread, and how we can perform the simulations of this digital thread part. Okay, then what is the advantages, why we are taking this digital thread part. Okay, the next is different or model-based enterprises are available. So for single applications, for product digital twin, how that system is functioning, for process digital twin, how it is working, and for service digital twin, how it is working. Okay, so this is all about digital thread. The next class will discuss about the digital twin. Okay, so thank you all.